Here we go. All right. Well, cool. Hey, everybody. Welcome again to Astronomy Daily Live. It is 2 hours UTC. And once again, we're here gathering together to, you know, gather in a circle or on sort of a virtual porch and get together and just think and talk all things astronomy. And isn't it great? I mean, I'm incredibly biased, right? But uh, nothing nothing really comes incredibly close to the joy that I feel when I'm thinking astronomical thoughts. The next thing down is probably music. Uh, um, but yeah, it's just one of those things, and I guess it is biased, right? Because you know somebody could say exactly the same thing for motorcycles, right? It's like when I'm working on a motorcycle or thinking about motorcycles, that is like the greatest thing in the world. So maybe it's a little bit of a bias. I don't know. Thinking about the universe, as far as I'm concerned, is is thinking really big, really big, and uh, that that's a pretty amazing feeling, right? To be able to uh, um, at, at least attempt to contemplate the situation we're in and try to figure it out, and why do things work the way they work and go the way they go, and why do things seem like this and they're not like that, and yeah, it just goes on and on and on. So yeah, I think that's um, absolutely fantastic, and that's why I like uh, all this all this stuff, because it's just it thinking those kinds of thoughts just brings me great joy, and I think that sort of means you're in the groove, right? Whatever groove you're in, um, if what you're doing is making you happy, you're probably in your groove. In your groove. So speaking of being in the groove, we've got some panelists again. Hey there, Bobby.
Hey, what's up?
Hope everything is well over there. And we have Tom also. Hey there, Tom.
Hey, good evening, everybody. How's it going? And that's a really great thing, Cosmic, when you can do something you're very passionate about as part of your job. So when those things meet up, that's great.
Yeah, I um, uh, when I first started sort of working in this profession, right? I mean, it was sort of a joke, right? But it's absolutely true. It's like, now wait, okay, let me get this straight. You are going to pay me to have the most fun that I could possibly have. Is that right? And it's like, yeah, and we're going to pay you a lot. It's like, wow. So I get to do exactly what I want to do, have loads and loads and loads of fun, um, and get paid to do it. It's like, wow. So yeah, that's how it is. I realize.
Huh?
What's that, Bobby?
And you don't have to ask for donations, huh?
Don't even have to ask for donations. Although of course, donations are always accepted. Yeah, but so yeah, that was sort of a running joke with me, that actually my coworkers didn't quite for some reason they didn't quite get it. They understood what I was saying, but I don't know. They just weren't feeling it exactly the same way. It was more of a matter of fact with them. It's like, well, yeah, I'm doing this work and I'm getting paid for it. And it's like, that's sort of the difference, right? I mean, work is activity that you don't necessarily want to do, but sort of have to anyway, right? And yeah, I can honestly say that the amount of work that I've done has been pretty minimal. So yeah, great fun. Anyway, that's the science of astronomy, and it's really great that we can sort of deal with this science at so many levels, right? I mean, that's why I say the science of astronomy is broad and deep. It's got this huge volume, right? Where the other sciences. Now, is astronomy like a subset of physics? Yeah, I guess it probably is. So physics might be a little bigger in terms of volume, but biology, right, is pretty narrow and really deep. Chemistry is sort of the same way, right? Sort of narrow and deep. But astronomy and physics, say, is this broad and deep, and that's why I like it, because there's so much, right? I mean, there's lifetimes and lifetimes and lifetimes of work that are of course, in terms of the past, yeah, lots and lots of works there. Right now, as we speak, right, there are people working on all kinds of astronomical things. And maybe one of you know, or somebody in the chat knows, what the population of like astronomers and say PhD type astronomers. I wonder how many of them there are, like, worldwide, or what the number of people are who consider themselves to be astronomers. I can't imagine that it's any more than like 100,000.
Yeah, I thought I'd heard some numbers that was even less than that, in the thousands, but not even that much. But I don't have an exact number on it.
Yeah, that's that's kind of interesting. Yeah, because I seem to remember seeing some kind of number too, and I don't remember exactly what it is. And I mean, it sort of depends on how you define that, right? And that's why I sort of changed my definition midstream there. It's like, how many people consider themselves to be an astronomer? Professional, right? I mean, I guess you have to clarify it that way. But yeah, I mean, there really aren't that many. I'm not quite sure how that compares to other sciences. And I guess the largest number there would be, like people who consider themselves to be scientists, right? Professional scientists. That's probably up over 100,000, I would say, pretty easily. Maybe 500,000. Not quite sure. All right, what did Uncle Bill post in the chat here? I'm gonna look. How many astronomers are there in the world today? Uncle Bill, you're just amazing. Okay, so, well, here, I'm going to, sorry, I meant to share my screen. I didn't. So let me share my screen here, and we will see. So this is the link that Uncle Bill put up in the chat. So how many astronomers are there in the world today? Okay, so they're saying, or they're asking here, how many now living individuals have a PhD in astrophysics, or by some other definition, can be reasonably classified as astronomers. So this answer, which is the only one there, says that the world, and this is some, okay, so this is from So You Want to Be an Astronomer by Duncan Forbes. Okay, I've never heard of that. Is that available? If there's a PDF of that, I might as well grab it and see if I qualify. I don't even know if I qualify. Okay, it looks like maybe not PDF. No, and it doesn't look like it. That's the closest I could get. I'm going to hide that. So, okay. Okay. Well, let's see what they say anyway. So the worldwide community of professional astronomers is only about 10,000. Most are located in the U.S. So what do you think about that? That's a pretty small number.
It's a pretty small number, and there's a qualification there that said they had to be PhD.
Well, you know,
Where's that?
they sort of mixed it up like I did. In fact, it's like, you know, first they say, you know, have to have a PhD, and then they changed it to, it's like, well, what somebody thinks. It's a pretty small number. So I don't know. That's, you know, that's probably...
It's always kind of like a bit crazy that it's way smaller than what you think and stuff.
Well,
but,
yeah, and I mean, I was a little bit careful there too, saying, you know, probably less than 100,000, which you know, I mean, 10,000 is obviously less than that, but yeah.
Another in the chat.
Okay, Uncle Bill is on fire.
Well, I would think anyone who's been paid to do, you know, various astronomy kind of things is a professional, whether they have a advanced degree or not.
Yeah, and it's also, you know, it's, you know, and there's sort of a difference between, you know, doing astronomy, the science, and doing astronomy, the engineering, right? So I mean, are you an astronomer if you build telescopes or, you know, make mirrors?
You know, how many astronomers we got in the world? I just like to know how much money does an astronomer does to get paid. I was thinking about this more like a salary thing and stuff.
Yeah, I can give you some pretty good numbers, at least from, well, and I don't think that these numbers have really changed all that much. A relatively well-paid research associate type of an astronomer can usually look to see maybe 50 to 60K a year or so. Sometimes it's a little bit more, sometimes it's a little bit less. There is, I think, at most universities, there is the what's the 7-year thing? The tenure.
Mhm.
Yeah. So I think a tenured professor probably gets at least 60 or 70, maybe even more. And then let's see, grad students don't, they get paid pretty well too. Postdocs are probably, are usually, like 40 to 50 or so. So yeah, and I don't think that that's changed all that much. Now I think that there are some who probably get paid even more. I mean, 6 figures probably. But most astronomers are the type where it's like, look, we're going to put this huge effort into writing a proposal for a grant, like from the National Science Foundation, right? And that grant is to either do a certain kind of work or build a certain kind of instrument or whatever it is, right? And it's like we need to put the money into that, not into us. So salaries and everything are usually pretty minimal, right? Because they want to put all that money towards the work. So I never really met a greedy astronomer who is in it for the money. That's just I don't think I've ever seen that. Money is a bonus, right? Like I said at the beginning here, it's like, okay, I'm going to do awesome things, and you're going to pay me too. It's just ridiculous, right? So yeah, okay, well, cool. Yeah, I mean,
From 50K to like somewhere around the 6-figure area, that's gonna be like pretty darn some good money though.
yeah, I mean, I would say the overall range is probably, and this is a pretty broad range, but I would say 50 to 150 is
I know
probably the
around
range.
here, around where I'm at, we're more of like industrial style since we're like close to the Gulf of Mexico.
Right.
And there's like a place called Ocean Area that really pays those people about up to 6 figures.
Yeah, and yeah, but like I said, I think to most astronomers, money is sort of a secondary thing. You know, maybe not as much as myself, right? But it's like if we have to get money, let's put it into the instrumentation or put it into the time needed to pay for a certain amount of work to be done. Um, so yeah, okay. Well, and conference attendance. I'm trying to think of like the American Astronomical Society has 2 meetings per year, right? They have one in January and one in June. Different places. I think I think they can go outside of the United States. I don't remember if they do or not. I think they probably do. I don't know, but yeah. Um, each meeting, it's always in a different place, and I'm I would think that the attendance at one of those has got to be it's got to be 3 or 4 or 5,000 for those big ones. like that. There's a lot of other ones, some smaller ones that can have dozens or hundreds. But the AAS is kind of the biggest one, and I'm thinking that they're probably seeing 4,000 or 5,000. So, let's be extremely generous and say 5,000 attendees at the AAS. Is it reasonable to assume that worldwide there are 10,000? Yeah, I think so. So maybe 10,000 isn't really that far off. It's pretty low, right? I mean, for what we're doing, right? What we're thinking about, what questions we're trying to answer, right? I mean, it's the astronomers who are asking these big questions, right? And there's only 10,000 of us. That's interesting. Yeah, very very.
Now about NASA, are they paying by the hour, or they have a salary as well?
I think, as with every kind of company, right? There is going to be a mix, right? So some employees are salaried and some aren't. So yeah, I think it's a mix. It sort of depends on your level. I think working for NASA.
How much money they're making, how much money they're putting in their banks. But if you're with, let's say you work with mission control or with launch control or something.
I think they are well taken care of. Yeah, those are pretty specialty kinds of positions, right? Where it's like there's only a dozen or two on the entire planet, right, that know how to do that. So it's a supply and demand thing, right? So small supply, the price is going to be really really high. That's just how it is. So yeah, I think those folks that you see at like mission control and all that, they are well taken care of. Yeah.
Now, have we ever found out how many members are there how many crew members are in the ISS right now, or no?
Yeah, right now there's 3. Is that right, Tom? Does that sound right?
Yes, that's right.
Okay. And since we're talking about that, what has anybody heard any new news about Soyuz? What the plan is?
The last I heard was that the Russians were saying that they thought they might be back on track in November, so they may have to do a little bit of a shuffle on the schedule, but it sounded like if it goes the way they think it's going to go, the crew that's there on the station right now may have to extend a little bit, but they wouldn't have to stay much longer, and there'll be some people joining them. Pretty much on schedule, but not quite. But it really depends on what they find in their investigation, and I haven't seen anything about that yet.
Yeah, and I wonder. I forget who it was talking about the fact that since this version of the Soyuz failed, they can simply go back to the previous version, which they knew worked, and do that. I don't know if they have those kinds of capabilities, but if they did, that sounds like a good idea. The other question that I have is who's going up? Is it going to be the same 2 guys, or is it going to be a new crew? And if so, it's like I mean, that that might be why they have to do a delay, because the next crew is still doing all the training and all the practicing and everything. I don't know. I don't know. What do you think about that?
Mm.
Well, you're probably right. If they do switch to the next crew and skip over the folks, the 2 guys that were on board, then yeah, the training schedule may dictate some of the launch schedule.
I when I watched the video of the failure of the Soyuz, they showed um, this clip of the astronauts as they were coming out of like a helicopter or something, had just brought them back, and both of their faces were like the saddest faces I've ever seen. It was just like, oh man, I mean, they both just look completely disappointed, and rightly so. I mean, it's like, oh man.
If I was coming out after that big failure right there, I'll be like, dang it, dang it, dang it, dang it, dang it.
Yeah, it's like, dang. I've been. I'm not quite sure how long the training is, but I would think they would. Training might last a year. I'm not sure. Maybe even more. And so they've been getting up every day.
Every single snafu that they ever had in the history of space exploration, like from like the disasters and stuff like that, to like almost have like like I mean from like Apollo 13 to Columbia, it's always like dang it, dang it, dang it, dang it, dang it. Something's got to go wrong.
Yeah, it's that's well, it sounds cliche, but that's life. That's how it is. It's like, we're trying to do this, and it ends up doing that. It's like, yeah. So there's always going to be accidents. There always is, right? I mean, air travel, I think, statistically, is like the safest way to travel that there is. Maybe even the most efficient, right? But I mean, it's so much safer than these suicide vehicles that we put ourselves into every single day. That's driving a car is like skydiving, right? It's like, is the parachute going to open when I pull the cord? It's exactly the same thing, I think, when I get into this car, right? It's like, what's going to happen? Is it all going to work? I don't know. Let's go anyway. So yeah.
Thank goodness we haven't even seen like a malfunction airlock door as it yet, and there goes a crew member drifting up in space. Rest in peace.
Yeah. I think I have a sneaking suspicion. That, and I'm not sure if the United States ever had any accidents in the early days that they didn't talk about. I don't know, but I'm a little bit more confident in at least entertaining the thought that maybe the Russians did, have some accidents with people that they just aren't going to talk about, right? I don't know. That's just a conjecture on my part. I don't think, I mean, these days, I watched the interview with the American astronaut who was part of the Soyuz, and he said, and I'm paraphrasing, but he said that all the safety systems worked flawlessly. I mean, the system detected something wrong, and it got them out of there, and worked flawlessly.
It's like kind of like a bit messed up that like let's say like you remember when one of I think it was in North Carolina when one of the when one of the fairground lights failed up, it passed inspection, and then next thing you know, throwing more on the rise, and like it just like a piece broke off, and it really killed some riders.
Yeah, well, and that's why I say, accidents will happen. I mean, or like I was going to say, with the airlines, right? They are like the safest mode of transportation that we have now, right?
Yeah.
And there are still accidents, right? I mean, and sometimes they're minor, right? It's like, engine fails or a tire pops or something, but sometimes there is a catastrophic failure, and so those, like I said, right, that's life.
Anywhere you go, you may think you may have success in the get-go, only to have an epic failure at the end.
Yes, sir. That's exactly true. That's exactly true.
You can do anything you want to stop it, but in the end, it's pretty much not in your cup of tea.
That's right. That's right. And when your number is called, you go. That's it. What number do you have? I don't know. But when it's called, I'm gone. Yeah, that's part of life. That's part of life's excitement. Speaking of life's excitement, I actually, before I get into that, I wanted to start reminding.
How old are you when 9/11 happened?
When 9/11 happened, that was 2000. I would have been 33.
Okay. So, like, within all these years, upon or so, yeah, I mean, like, 9/11, you just have a very good, beautiful day, and then next thing you know, those towers fail and stuff like that. It was, like, just one big, well, it was easy day turned into a nightmare.
Yeah. I always think about, the people going to work that day and, waking up like they always do, doing their morning thing.
Kids ready for school, dads ready for work, and then next thing you know, boom.
Yeah, and most of them didn't really even have a chance to realize, right? I mean, it was way too fast of an event. So, but yeah, I think the only relation to astronomy that has is gravity. So hey, I wanted to start letting everybody know that I am going to be on an extended trip starting on the what'll be UTC the 1st of November through the probably the 5th of November. So those 5 days. Is that right? Yeah, those 5 days there will be no live stream.
So where you're going to be going at?
Me and my musical partner are going to. I forget actually what it is. it's some kind of a conference up in Laughlin, and they want us to play up there. So they want us to do a opening ceremony, and then give like a 2-hour or so concert. So yeah, and we've been given passes to the conference, so we can go to that, and I don't remember what it's about. And free rooms and
music conference.
What's that?
It's an ambient music conference.
No, it's not a music thing. I'm trying to remember. Yeah, it's some kind of scientific thing of some sort, but I don't remember what it is. Because we're there for the music. I mean, obviously it wasn't interesting enough to remember, but yeah. So I mean, that's actually starting 2 weeks from today. I believe 2 weeks from yesterday. So yeah. Just a reminder that on those five days there will be no live stream. I might try to live stream from up there using my smartphone, maybe, but that'll sort of be at random times, if at all. So probably not at all, but you never know. Anyway, so yeah, starting the 1st and going through the 5th, no live streams. So the next one after that will be on the 6th.
And that's UTC time, right?
UTC, correct.
By around that time, I think like me and Tom should all be on Standard Time by now.
Yeah, I think the fallback is happening probably the weekend of the 3rd, maybe.
I think that's right.
I think, Tom, it was on the 4th, right?
3rd or 4th, yeah.
Yeah, that weekend. I don't remember what the dates are, but yeah.
So guess what? We might have ADL on the 6th at my local time at 8 o'clock.
Yeah. All you guys shift.
Yeah, we do.
Just do the little shift to the fall. So yeah. So of course, where I am, Mountain Standard Time all the time. So we don't have any kind of daylight savings time here, and so, but relatively speaking, we all shift relative to one another. So yeah. But anyway, so okay, so that is the reminder about that. Another reminder is that coming up on, I think this is UT also, on the early morning of January 1st, 2019, New Horizons is going to be going by Ultima Thule, I think is what they're calling that trans-Neptunian object. And so that, just as a reminder, that is going to be a pretty interesting event, I think. I haven't been following things too closely, but they're, at least the last I heard, they were getting some kind of indication that this was some kind of a binary object. I don't know. Has anybody else heard anything new about that?
No, I haven't heard anything new. Been pretty quiet, so I guess things must be going well with it.
Yeah. I'm not quite sure even what the plan is. I would, I mean, it depends on lots and lots and lots of things. But I would think that if they could, they would be taking pictures as they get in. But maybe they're trying to conserve. I don't know. Yeah, the bit rate on the spacecraft itself is extremely low, and so New Horizons has to store all that data, and there's only so much space, right? And then you run out of space. So yeah, maybe they're having to conserve. I'm not exactly sure, but yeah, it is definitely going to be a pretty interesting event. Now, of course, it's just a flyby, so they're just going to buy it. But as I recall, it's coming in really close. I mean, like almost scary close.
Like the images that New Horizons did for Pluto and stuff. I think that was pretty darn good.
Yeah, and Bobby, that data is going to provide lifetimes worth of work. It's just because I mean most people have only seen the pictures, right? But there is magnetometer data, there's plasma data, there's radio data. There's just all this tons and tons and tons of data. What I wanted to do was just Google. I'm not going to share my screen. I'm just going to look it up here really quick.
And
New Horizons.
Uncle Bill, I think it's still only a pixel at this point. That occultation a few months ago is probably the bulk of what we know.
Okay. Yeah, I think yeah, maybe it was varying in brightness or something like that. Yeah. I don't remember. Let's see, Pluto extension. Encounter with. So let's see. So yeah, it says here that New Horizons is planned to come within 2,200 miles of this object. So that's insane close. Yeah, they actually say here it's 3 times closer than what it got to Pluto. So yeah, that is crazy close. Resolution up to 30 meters per pixel. So 30 meters isn't really. I mean, that's really big, right? I mean, that's what? That's the size of a football field, isn't it?
Yeah. Yes, it is.
Yeah, so that's pretty big. That's a big pixel. I mean, it's going to be stupendous, right? And it's hopefully, probably, going to be just as surprising as Pluto was. And that's what I like best. Is that right now we have no idea, but in like 2.5 months, we're going to have 30-meter pixels. So awesome, very very awesome. And
how many pixels? 30 million.
30 meter. So one.
30 meters.
Yeah. So one pixel will show 30 meters on a side.
New Horizons with all that instrumentation is still only the size of your refrigerator. Tiny low power transmitter, low bandwidth, and slow downloads.
Slow. You know what slow is? It's 40 bits per second. Slow.
Well, it's billions of miles away.
Yeah, and they wanted to pack as much scientific instrumentation in as they could, so they compromised with the bandwidth. It's like, let's store this data at as high a data rate as we can possibly get, right? and then just trickle it back to Earth. That's it. That's it. So I mean, it's absolutely brilliant because you get more data, more science, right? It just takes longer, right? I mean, it took them like a year and a half, right, to download the Pluto encounter. Is that about right? It was a year and a half.
Yeah, it was 18 months from the flyby.
Yeah. So yeah, and I don't think that was continuous, but maybe it was. I'm not sure. The Deep Space Network, I mean, at least rotates. So I would think that they would have to switch off at least. And the Deep Space Network is servicing more and more spacecraft too. So yeah, they have to go all over the place now. So, but yeah, the reason why I brought that up is because I saw.
I never knew that New Horizons would be like super small than like any other objects in space.
It's pretty small, but it's packed. It is packed and packed. Yeah. So great instrumentation, and except for that little weird event right before Pluto encounter, it's behaved perfectly, flawlessly. So good engineering there. The engineers who build these spacecraft are they've got to be geniuses, right? Because they make these spacecraft such that even if the spacecraft fails in one way, they can think about it, and it's like, okay, let's do this, and either totally recover it, or put it into a mode that actually makes it even more useful. So yeah, it's absolutely amazing. These engineers are great. But anyway, the reason why I brought New Horizons up is because I saw a paper over on archive.org that looked kind of interesting, and I just wanted to look at it with you. I'm going to hide that, and I'm going to go over to the Discord, because I put it there. So, return to the Kuiper Belt. Launch opportunities from 2025 to 2040. So they are thinking about, what objects are sort of available out there in the Kuiper Belt that we may want to throw a spacecraft towards. And I notice here that Alan Stern is one of the authors. Makes sense. In fact, they're all from from the Southwest Research Institute. But yeah, so let's see here. So preliminary spacecraft trajectories for 45 KBOs and Pluto suitable for launch between 2025 and 2040 are presented. Cool. Okay. So they have found 45 objects to launch spacecraft towards. Cool. Trajectories are modeled. Okay. Fast launch with a Jupiter gravity assist. So with a single Jupiter gravity assist, all 45 KBOs and Pluto can be reached within a 25-year maximum mission duration. Wow. I don't know if I would want to be involved with a mission that is supposed to last for 25 years. Yeah, wow, that's that is definitely a commitment.
Yeah, they usually don't have missions like that anyways, so I think this
Yeah.
is just these guys saying here, this, you could be done, so
Yeah, yeah,
out
yeah.
of these 45, pick some out. And
Yeah, that sounds, well, like I said, you know, the title of this is like, wow, that's pretty nice. Let's sort of see what they're after here. There's probably at least going to be some tables. Okay, so here they're talking about the Kuiper belt.
you're looking for the pictures, aren't you?
I look for pictures and tables. All this text is just too
That'd be
confusing.
great. Like if they show you a table of how much great opportunities we're going to be looking at if we resolve the ones of those objects, those spacecrafts around those periods of time.
Yeah, yeah. No, I'm expecting that, but they, you know, they have to explain how they arrived at this list, and you know, I'm sort of going for the list. So yeah, let's keep going here a little bit. This is extremely interesting, sort of their methodology here. It's quite comprehensive. Let's see. Jupiter mission summaries. Here we go. List of KBOs with Jupiter swing-bys, their possible launch years, and the minimum mission duration for various amounts of maximum C3. I don't know what C3. What is C3? Pluto missions with much lower C3s. There's a C3 trajectory. C3. This is how you find out what a C3 is. You keep going back in the text until it isn't mentioned anymore. And then you go forward in the text until it is. I don't see it anymore.
Well, I thought there was some acronyms listed at the top of at the beginning of this thing.
Oh, was there?
Yeah.
Oh, yeah. Here you go. Excess launch energy. Huh. Okay. All right. Okay. Cool. All right. So here's the table. Zoom that up a little bit. Okay.
It does to list lunch like all the time. Around this time, you could be definitely launching craft to Jupiter at any given time around that period.
Yeah, I think. So
and,
this. Yeah, this is
the rest of the data I'm looking at right now. If you don't get those opportunities, you may never get them again.
Yeah. See, here, right? To encounter Jupiter, you've got a very, very wide range of time. But if you want to encounter this guy, right? At least how I'm interpreting this is that you only have this range of launch, right? So you have to launch it in that 2-year span, or you might as well not do it at all, right? And then depending on how much push you give it, this is the number of years, the minimum number of years it'll take to actually get there.
So this is really just a menu that they can use to decide what they want to do.
Yeah.
Pick a couple things out of the menu that fit together and go.
Yeah. And it's a pretty enormous list, I gotta say.
Yeah,
pretty nice.
I can see the space launch organizations do something like that, like space tests and stuff.
Yeah, yeah, yeah. No, this is this this is pretty neat. You know.
Yeah. Um, if they can open base those spacecrafts, that would be like pretty darn good because we love to see data ourselves, not just like the people that's doing it.
Yeah, yeah, yeah. Of course, of course. So, yeah, pretty interesting, pretty neat. Um, I'd like to sort of get a plot showing, uh, uh, maybe a little bit more clear in terms of how these things relate. But yeah, very, very cool. And some of these are going way out there too. 95 astronomical units. That's pretty far out. I think Pluto is about 30 or 40, something like that. So yeah, I mean, obviously these are Kuiper belt objects, which I think by definition have to be like 30 AU or further out. I'm not exactly sure what the limits of the Kuiper belt are, but yeah, these are pretty far out. So I mean, all of these missions are taking quite a while, right? I mean, I'm seeing a lot of 9, 11. Even for the fastest ones, right? I mean, these are not short missions. This one is pretty short, but he's also, pretty close in. So yeah, these are pretty long. These, yeah, these could definitely, require a commitment. What they were saying, the longest one here is like 25 years. Yeah, here's a 23.6. Oh, Make 1. They have a 2-year window. Huh. Let's see. Yeah, here's a 22.5. 23.4. Yeah. Pretty neat, though. That's a nice... I wonder what else they've got here. If they have other... Let's see. The list of KBOs with Jupiter and Saturn swing-bys. Okay, so, right. The previous one was just Jupiter. So this is now Jupiter and then Saturn. So there's a Saturn 1 and a Saturn 2. And then, yeah, there's a few left. There's a few left. I don't know. I mean, it almost seems to me that you're more limited with a Saturn flyby. At least in terms of numbers, right? I mean, that's significantly less. I wonder why they would want to even consider doing a Saturn swing by. Don't know. Maybe it changes the launch range. Maybe it, I don't know. What do you think?
I would think they would only do that if it helps cut down the time, gives them more speed to get there quicker with less fuel and all that.
True. That's a consideration also. Well, let's see. Let's look at. Let's see. How can we do this? Let's look at 2002 MS4. Okay. Well, okay. Let's look at the dates first. So 2002 MS4. We can go back up here. 2002 MS4. Okay, this actually has 2 possible encounters. So this is 2027 to 2031. And this one is 2038 to 2040. So it's a narrower window. And 18.6 for the first 2. Let's see. Huh. It takes longer. So it's a slightly narrower window. Oh, 2027 to 2031. What did this say?
I think we do have the technology that we can have to like open base those spacecrafts, like put them like in a range of SDRs and tabletop receivers, and then like maybe we can always like get the data in some form or some way, and we can always like share it around like on Facebook and stuff. What do you think?
Well, I think that's a grand idea, but there's at least one problem that you are going to have, and that is the signal strength. The signal strength, the typical signal strength for a spacecraft is, well, I do know, well, yeah. I think most of the Mars spacecraft, I think their power level when it reaches the Earth is about negative 150 dBm. So that is a incredibly minuscule amount of power, and so in order to deal with that, of course, you need a big telescope. So unless you have,
like a Helico or something, huh?
Well, no, you need like a here. Let's I'll show you what they use. Okay. Let's see. Am I sharing my screen or not? Yes, I am. Okay. Let's go over here and look at the Deep Space Network. Here we go. Let's just do this one. Let's see if we've got there's our pictures. So here's the 70-meter antenna at Goldstone. So this is 70 meters across here. So that's what you need in order to communicate with spacecraft.
Now, I'm wondering if you get that same type of data by just using like a direct TV dish.
No.
Dang.
Not a chance. Not a chance. Because as I said, the signals are extremely low, right? 0 dBm is 1 milliwatt, right? Negative 150 dBm is 10 to the minus 15th milliwatts. No, 10 to the minus, yeah, 10 to the minus 15th milliwatts. So it extremely small signals require a huge light bucket. That's all this is, right? It's a light bucket. It just so happens to be radio light as opposed to, visible light. Same thing though, right? This is a big huge mirror, reflects the radio light here. This reflects the radio light down to a detector that is probably down here. So yeah, works exactly the same way as all telescopes do. This has to look in the radio, and it's so big because it needs to see an extremely faint signal. So yeah, unless you build one of these, Bobby, you are not going to get any of that data. And well, yeah, I I'm not quite sure. It probably depends a little bit on the spacecraft, but I think most spacecraft are pretty directional too, right? They want to try to put as much power as they can into one sort of beam, right? Yeah. So, and I think that's actually one of the reasons why the New Horizons signal is as weak and as slow as it is, because I think that's an omnidirectional, maybe not omni. Yeah, don't take my word for that, but I think so. They didn't have room for any kind of directional antenna, I think. And maybe I'm wrong about that too, but yeah, I think so.
And here comes this ding it for jealous observers like me and you and maybe Tom and stuff.
Yeah. Anyway, so yeah, you need a big telescope to listen to those guys. Okay, so where were we? We were looking at what were we looking at? We were over here, weren't we?
Peeking at that paper.
There we go. Yeah. So, I mean, from what I'm seeing, this is a narrower window of opportunity, and it's going to take longer. So
that's with the flybys?
With the Saturn flyby, yeah. Yeah.
So I wonder if it's just a difference in the fuel, or...
Yeah. Either that, or you do get a Saturn flyby. I mean, that's
true.
That's got to count for something.
Right.
Oh, okay. So they also do a Jupiter-Uranus, I guess. Let's see. Yeah. Okay. So this is now that would be, I would say that would be extremely valuable, right? To have a Uranus flyby, that would be fabulous, right? Because Voyager was there, but
it's been a long time.
It's been a long time, and well, look, there's see again, there's not very many, but what is really cool, right, is that they've worked this out, and it's like with a Uranus flyby, they can also have these secondary encounters, just like New Horizons is going to do, right? So yeah, I think that's probably what it is, right? It's like, okay, what the compromise is that, look, we get Saturn and something else, as opposed to just one thing, right? And okay, that's starting to make sense, right? I mean, if you aim your spacecraft just for the target, right, then you can definitely minimize your travel time, and yeah, that's the best route. But if you want some bonus, right, you can have Jupiter or Saturn or Uranus, and I wonder, Neptune. Oh, Neptune would be great too. So yeah, that makes sense, right? It's like, either you're going to aim for your target and shoot right at it and get there really fast, or you're going to aim for Neptune, and if you configure the trajectory right, you can also have one of these. So that's cool. That's all right. And yeah, I mean, look how fast, right? 7 years. 7 years to Neptune. How? Let's see. Voyager 2 was launched in 70. Was it 77 or 70? Yeah, it was 77, right? Voyager 2. Actually, both of them were launched in the same year. Was it 77?
I don't remember. But
we have to know. We must know. I've said this before. If I was a kid today, I would be. I don't think anyone would ever see me because I would be like completely, doing all kinds of internet things. I mean, when I was a kid, right, my internet was the library, right? And so that's where I was. I was at the library. Yeah, August 20th, 1977. And I believe it got to Neptune in 89. Yeah, August 25th, 1989. So it took Voyager 2 12 years to get to Neptune. And they say that they can get to Neptune in 7 years. In 7 years. And then have this really, really cool opportunity to go after these other guys. Now these missions are long. Look at this. There it is. If you want to go to Sedna after Neptune, you've got to wait 25 years. Wow. And you have a very, very short opportunity. Wow. This is really great. This is really, really interesting. This is some really cool work. Okay, so let's see. This is the list of KBOs. Didn't we just see this? What's the difference here?
that one was Saturn.
Yeah, but didn't we see this list before? Oh, maybe this is. Yeah. Okay, so the previous ones we were doing was actually a Jupiter, and then next planet, and then the KBO, right? This, I think, is just going to Saturn first, right? Is that right? Am I? Yeah. So this is. I went too far. So yeah, okay. Well, it gets even better then, right? Because with these, right, you get Jupiter, you get 2 opportunities at Saturn, and then you get all these. Okay, so very, very cool. So, okay, so this then is going straight to Saturn first. So you're not going to Jupiter first, you're going to Saturn first. Cool. Okay, so they do exactly the same thing, I'll bet, for Saturn. Wow. So Saturn in 2 years. Wow. That's fast. Doesn't that seem a little fast? Saturn in 2 years. That's over 1 billion miles, right? Wow.
Took Cassini longer than that, I think.
Yeah. Anyway, so yeah, there's Saturn and well, quite a few after Saturn. That's cool. So then Saturn, Uranus, Saturn, Neptune. Okay, now how far do they go here? Okay, I was wondering if they would do a Uranus and then a Uranus Neptune and then just a Neptune, but maybe they didn't. Doesn't look like they did. They did not finish the pattern. Oh well. All right.
So
Well,
those patterns can change at any given moment, right?
sure. With Saturn and Neptune. Huh. Okay. I don't know if I'm really following this. List of KBOs with Saturn and Neptune swing bys for possible launch years and yeah, blah 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 blah. But so here's oh, I don't know if I'm not quite sure if I'm following this. Gonna have to think about this one a little bit. Huh. All right. Well, I'm not going to take too much time because I'm slow about these things anyway. Let's see. Future work in conclusions. 45 of the most notable KBOs. Of course, new KBOs are being discovered every day. So yeah, that list, I would say, could definitely be highly modified in the next several years. But yeah, if they want to be starting in 2025, they better get moving. They got a spacecraft to build. Let's see. Okay, yeah. Cool. So we found that all 5 of the non-Pluto KBOs can be reached. Eris and Sedna. Quar, I don't know how to pronounce that. Makemake. Iomea. Varuna. Oh, I didn't know anything about a fast rotator. Varuna. That's a cool name. Yeah, nice. I vote for a Uranus-Neptune encounter, and then go after a KBO, but they don't show those here. So,
Well, here's your opportunity to write a paper then.
yeah, that's wow. That I'm gonna have to pull out my celestial mechanics books and and get right to that. Yeah.
Get your slide rule and your calculator and start going.
Yeah. I think what I would do is I would contact this lady here and say, hey, why don't you do it for the rest? And see what it looks like. And because they probably have done that, or they have code already written that could probably.
Or they do give you like a snail mail address. Maybe you should try that.
Yeah, it's easy enough to get onto that website, and I'll bet you I'd be able to find an email. You might be able to
find an email then.
Yeah. There he is right there, Alan Stern. I wonder how many emails he gets every day. Let's see, but let's see. She's an asterisk. What does the asterisk say? Oh, there it is, right there. Right there.
Yeah,
so, yeah,
they're all there.
Yeah.
There's your emails right there, baby.
Yeah. So that's an invitation to, and I actually will probably go ahead and do that. See if they've worked that out for a Uranus encounter, and then a Uranus-Neptune encounter, and then a Neptune encounter. Yeah. All right. Well, cool. Hey, it is pretty much past time here. So yeah, I just thought that I would share that along. It's these kinds of missions of discovery. Almost regardless of where they're going, or what they're doing are really 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 exciting, because it's completely new, right? Completely new. We don't have we have absolutely at this point, right? We have no really really good idea about what any of these things look like, what they're made of, what they're doing out there, right? Why are they there? How'd they get there? Um, and to have the opportunity to sort of fly by one of these things, do some early recon, right? And try to get an idea of what they look like, what they're made of, all those things. Um, and right now it's like we're practically clueless, right? I mean, not totally, of course, but we're practically just nothing, right? Don't know anything at all. And so new frontiers are always extremely exciting, and regardless of what it is, right? I mean, for me, I don't care. It's new, and yeah, it's a pretty exciting time. It's a pretty exciting time, and it's busy, right? I mean, there's lots of spacecraft, and they're talking about 45 new opportunities. I mean, in theory, right? Not going to happen. That is 45 missions, right? Over the course of what 15 years or so. So yeah, that's 3 missions per year. That's yeah. I mean, it's not going to happen, sadly. And maybe after a while, how much is too much, also, right? So I mean, is going to 45 of these Kuiper Belt objects is are we going to learn anything new after the 5th one or the 10th one? I don't know. But yeah, it's nice to have that kind of work done. That's some awesome work. For what it's worth, my compliments, because that is some really 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 cool work that was presented in such a easy way, except for that last table. I have to understand that one better. But yeah, absolutely great work. Exciting too, right? And makes me think of what's to come. It is going to be interesting. It's going to be interesting for sure. And I think the New Horizons encounter is going to blow our minds. I really, really do. I think it's going to be a pretty interesting thing, for sure. All right, you guys, I'm going to get out of here for now. I've barely drunk any of this today. It's just just one of those days. So cheers. And with that, I will see you all in a little less than 23 hours from now. Just a little less than one spin. So hold on to your hats and don't fall over. It's a pretty smooth ride, but yeah, I think we will meet again tomorrow, some 20 million kilometers sort of that way. And so I will see you there, and I will see you then. All right. Take care, everybody. Bye.